A railway platform is an area alongside the railway track providing convenient access of trains. Almost all stations have some form of platform, with larger stations having multiple platforms. A platform gap is the space between a train car and the edge of the station platform, often created by geometric constraints, historic legacies, or use of partially compatible equipment. Platform gap fillers are movable platform edge extensions at subway or railway stations where the curvature of the platform creates a significant gap between the platform and the subway or train car door. Mechanical platform edge extensions, known as platform gap fillers, may be used to bridge the gap between the platform and vehicle. Mechanical gap fillers shall be able to fill up the gap between the platform and the train door for the preventing passengers falling into the platform gap. The MGF shall be a self-sustainable modular design which enables installation work to be completed individually in the operating railway during the non-traffic hours at night time. The installation work at the platform edge would require specific booking of track possession on designated nights. The partly installed MGF system at platforms shall be self-contained and shall not cause any disruption or inconvenience to the normal railway operation or tripping hazard to passengers. The MGF shall be able to operate independently even without the completion of the whole installation of the MGF along the platform. All materials, details, equipment, and workmanship which have no specific standard specified in contract shall comply with the relevant EN or BS standards or the equivalents. Electrical or electronic devices or enclosure of electrical devices should have a degree of protection not less than IP65 in accordance with the IEC 60529 or EN 60529. The contractor shall comply with all local regulations and satisfy the requirements from owner. The safety integrity level of the system shall be CL3 in accordance with EN 50129. The system design and development shall comply with the requirements as stipulated in EN 50129. The material of the system design and development shall not be a cause of flame to spread and emit toxic gases in case of fire. All material shall be non-combustible. The system shall always maintain a safety state in any circumstances, including startup and shutdown. Failure of single components or subsystem of the system shall not result in spurious movement of MGF. The design life of the system and the major components shall be at least 20 years with minimum maintenance. Styling and architectural design decisions shall be based on both functionality and the needs of passengers. The MGFs themselves shall be elegant and integrated with the platform structure. Details shall be uncluttered, straightforward, and rational. Fresh finishes with concealed fixings shall be used wherever possible. The MGF shall be fabricated with a suitable material which can minimize the weight of MGF while it can withstand all required loadings. The mechanical gap fillers can be folded type. The surface of the MDF shall be heavy-duty, wear-resistant, and finished with anti-skipping pattern. The maximum gap to be filled by mechanical gap filler is approximately 300 millimeters. The filler plate and the supporting linkage shall support weight of passengers, passenger on wheelchair, and as well as luggage carried by passenger. The filler plate shall be flush with the platform edge surface after the filler plate is raised. The operation of mechanical gap filler shall cause any damaging contact with the train throughout its full swing or stroke. The setting of the MDF shall be in line with the train doors at normal stopping position. Variation on the train length shall be considered when deciding the MDF length. The preliminary sequence of actions are listed as follows. Train approaches platform. Train stops. MDFs raised if the stopping accuracy is within the set tolerance. After the MDFs are fully raised, a confirmation signal is sent back to the signaling system. Train doors open. Passengers boarding and lighting. Train doors close. After train doors are fully closed, a confirmation signal is sent back to the MDF system via signaling system. MDFs lowered, visual audible warning may be given. After the MDFs fully lowered, the confirmation signal will be sent to the signaling system. The status of the MDF shall be displayed in the MDF status trackside indicator. Train departs. The interface signals with the signaling system employed in above operation sequence shall be bidirectional signals with double cut circuit design, voltage-free dry contacts, and the relay complying with BR 930 or equivalent shall be adopted. The contractor shall coordinate with the signaling system to develop detailed operation sequence and the requirements of interfacing signals. Train operated in ATO, automatic train operation, or ATP, automatic train protection mode shall have control on MDF system via signaling system. Train stopping accuracies in different mode of operation is plus minus 500 millimeters. The normal frequency for the operation of the mechanical gap filler shall be 1 cycle, operate and return for 2 minutes, or the highest frequency that the signaling system can allow during the operation hour. The contractor shall note that the actual number of operations will be higher than the normal frequency due to recycling of train doors due to operational reasons. The response time, which counts from receive of valid command from the signaling system to MDFs fully raising from its normal position to operational position, shall not be more than 1.5 seconds. The MDF shall return from fully operational position to its normal position within 1.5 seconds after receiving valid command from signaling system. The above response times shall include the response times for sending confirmation signals to signaling system. MDF unit shall be at the platform edge and align with train door. It shall be a self-contained unit, which includes control equipment and the drive mechanism. The casing of the unit shall prevent the ingress of rainwater. Drain holes shall be provided to prevent flooding within the unit in case of failure of sealing. Casing of MDF unit shall be made of suitable material which can take up all structural loading throughout the design life with minimal maintenance. Surface of the MDF unit shall flush with platform edge structure, heavy-duty, wear-resistant, and finished with anti-slipping pattern and material. The contractor shall ensure that the interface with existing platform edge shall be durable and not introduce tripping hazard. Structural interface with the civil provisions shall be simple and allow quick installation during non-traffic hours. The partly installed components on the platforms shall affect the boarding and the lighting of passengers during traffic hours or induce any tripping hazard. Installation methods shall produce low noise level which complies with the relevant regulations. Electric drive shall be adopted for the driving mechanism. Design of driving mechanism shall standardize the dimensions of filler plates for the MDF units with different strokes, distance for the filler to travel for filling up the gap, hence to ensure interchangeability of filler plate. The MDF control unit, MIU, shall be the controller of the individual MDF unit and the interface with the MDF interface unit. All local operations and controls shall be performed and controlled by the MCU housed in the MDF unit. Filler plate is a movable plate which fills up the platform gap for boarding and the lighting of passengers when it is in operational position. It shall return to its normal position by folding down below the platform edge and allow train departure after platform duty. The outer edge of the filler plate shall be made of rubber fingers to allow maximum intrusion of the KE. The contractors shall standardize the size of filler plates for different MDF units. At each MDF unit, there shall be an array of indication light which will illuminate when the MDF is not in a folded down position. The indicator light shall be of LED cluster type and installed in the position where it is easily observed by the staff at platform supervisory booth. The MIU MDF interface unit is the control cabinet in which the signal system and the MDF interfaces are connected, and at each which control signals are marshaled and transmitted to and from individual MDF unit and panel. The MIU will serve as the central communication of the MDF system with the other systems, externally or internally. This arrangement will centralize all the signal flows in and out of the MDF system, which will be more convenient for the maintenance staff to carry a primary check of any fault reported from the MDF and locate the root cause. The MIU shall provide a visual display of MDF operational statuses and alarms. All input and output signals, events, and alarms shall be stored in the MIU. The MIU may be located at platform and shall have a degree of protection of IP65. MSP, MGF status panel, will be located at the strategic location, including SCR and PSB. MSP shall display operational statuses and alarms of the MGF system. Individual status of MGF shall be displayed on the MSP. The MSP has visual display and audible alarm, which alert the platform staff to any abnormal conditions of the MGF system. A mute button for staff to acknowledge the alarm is provided on the MSP. The buzzer shall be programmable to be muted automatically within a preset period or disabled. Major alarms and the status signals shall be connected with the hard wires from MIU to MSP. MLP, MGF local control panel, will be provided at head wall and tail wall of each platform which has an MGF system installed. The MLP shall provide indication of the system status and provide a platform level control of the MGF system. A bypass future interlock override shall be provided by bypass the departure confirmation signal to signaling system if the signal is not confirmed and not for operational reasons, it is required to bypass the signal. The MLP shall have a degree of protection of IP65. MGF status trackside indicator made up of LED array shall be provided at each end of each platform to show the clear and true indication of MGF statuses to the driver and train cab. The indicator shall illuminate only when the MGFs of the respective platform are in normal positions. MGF power supply equipment, PSE, shall be fed from station power supply and regulate the power for the MGF system. PSE shall consist of power supply units of control power and drive power to MGF units. PSE shall have the capability to maintain the supply of control power for 30 minutes and drive power for 3 operations in 30 minutes in case of failure of a station supply. All supply voltages shall be DC and shall not exceed 110 VDC. All major control and monitoring equipment and subsystems shall be fed from control power supply. The PSE may be located at platform and shall have a degree of protection of IP65. The contractor shall supply and install cable containment for the MGF system. The monitoring system shall provide indications of the statuses of the MGF system. The statuses of monitoring points will be sent to or displayed at MIU, MLP, and MSP. A list of alarms and the statuses to be recorded in MIU and displayed in MIU and MSP shall be submitted for review. Detection of object or passenger or filler plate shall be provided to prevent lowering of filler plate when object is sitting on or passenger is standing on the filler plate. This shall be a fail-safe detection. Positive output of this object detection device shall inhibit movement of filler plate. The object detection shall have sufficient coverage of the filler plate. Small objects, such as ladies' high heel and the lightweight object, shall be detected by the object detection system. Alarm shall be sent to the MSP and the local warning shall be provided on detection of object after train doors are closed. The contractor shall propose different detection methods for review and consideration, which may include pressure mat, load cell, limit switch, infrared scanner, image recognition, ultrasound sensor, or their combination. The selection of object detection shall consider the adverse out or trackside environment and the interference due to the exposure to direct sunlight and heavy rain. MGF shall provide the obstacle detection function. It shall detect the obstacle while lifting and loading. It shall recycle for several times if the obstacle present and raise alarm if the MGF failed to move to required position after several attempts. The obstacle detection shall also prevent the trapping of passenger's shoe or other object. It shall also limit the force and the energy of a moving filling plate to prevent the passenger from injury. The contractor shall propose a suitable method to prevent and detect the passenger falling into the platform gap between two adjacent MGFs where the gap is in excess of 250 millimeters. At each MGF unit, a local manual selector switch, which is easily accessible at platform, shall be provided to set a particular MGF in the automatic, isolated, or maintenance mode. When an MGF is in automatic mode, the MGF shall be under control and monitoring of MIU. When an MGF is in isolated mode, the MGF shall not be controlled by the MIU, but the status of the MGF shall be under the monitoring of the MIU, and the status of the isolated MGF shall be included in the departure confirmation signal, the signal system only. The drive power to the isolated MGF shall be removed. When an MGF is in maintenance mode, the MGF shall be still under the status monitoring of the MIU and the signaling system. The MGF shall be able to be controlled by the local control buttons housed in the MGF unit. The selector switch and the local control button shall be properly located and covered to prohibit access or tamper by passengers. In case of MGF unit does not function normally, visual and audible warning signals shall be given to the waiting passengers on the platform to remind the passengers of the abnormality. The audio alert shall be audible to the passenger near to the problematic doorway. Mechanism for emergency operation shall be available for staff to manually operate the MGF unit without access from trackside. This emergency loading mechanism shall be fail-safe, fail-proof, easy to operate, and efficient to avoid affecting train traffic. The mechanism shall be able to reinstate the filler plate into normal position within 10 seconds with a clear physical indication of locked position of the MGF. MGF units shall be fixed to the platform structure. Fixing details shall be coordinated with civil works contractor. The interface design shall allow minimal site installation works and consider the tight installation schedule. The contractor shall submit design to show how the MDF is fixed to the existing platform structure. MDF shall be designed and constructed to withstand the loads and the combination load conditions. No movement or deflection of any part of the MDF to trackside is allowed under all different load conditions. The passenger load is 3 kN per square meter. The MDF, including filler plate, shall be designed to operate under this loading throughout the design life of the MDF. The filler plate shall be designed to withstand a load of 2.5 kN applied along the leading edge of the filler plate. Any part of the filler plate shall not deflect for more than 5 mm and shall not deform permanently if the load is increased to 3.5 kN. The filler plate shall restore to its off-load position after removing the load. The filler plate shall maintain a fully operational position even a horizontal force of 1 kN applied from the trackside during passenger boarding. Earthquake force shall be deemed to be included if structures are designed to additionally resist the loads and the forces created by an ultimate horizontal or vertical acceleration of 0.07 gram. The design of the MDF shall be fail-safe. Failure of any mechanical device that raises the MDF, for example, motors and gears, or that enables it to stay in position, for example, brake or lock, shall not cause any hazard to passengers. The filler plate shall be held at extended position by means of mechanical lock or brake. Duplicated position sensors shall be provided to achieve higher availability and to provide a clear and true indication of the status of the MDF. Failure of one of the sensors shall prompt maintenance a lot. When there is a drive power failure, the filler plate in motion shall be controlled to react in a means that shall not cause any hazards to both trains and passengers. The MDF shall be equipped with mechanical lock or brake to maintain the MDF at normal or operational position in case of a power failure. In the event of a train hitting the filler plate for whatever reasons, the filler plate shall either be reinstated in its normal position or detached from its supporting structure without damaging the train body and MDF or causing passengers to get hurt at platform and on board of train. The design shall also safeguard the passengers at platform. The contractor shall submit detailed design and calculation and conduct type test for demonstrating the compliance. Warning strip or hatching pattern shall be provided at the edge of the MDF to prevent the passenger from falling to gap. The MDF shall be designed so that passengers can easily distinguish the MDF is at the normal position or the operational position. The design and the construction of the MDF system shall enable regular and reliable operation to be achieved for the system design life. quick recovery mechanism of MGF shall be provided. Any failure within the MGF shall be rectified or bypassed such that train service delay due to MGF failure shall not exceed 8 minutes. The mean cycles between failures, MCBF criterion is set as not to exceed 1 failure per 300,000 cycles. The service failure rate of MGF shall not exceed 1 failure per 2 million cycles. The service failure is the failure as a result in train service delay of more than 3 minutes, but less than 8 minutes. The MCBF is measured in system-wide MGF installation. A cycle with one complete operation cycle of the MGF unit. A good system design, maintenance procedures, and the suitable spares holdings are necessary to ensure the availability requirements of the MGF system. The availability of the system shall achieve 99.99% or better. The MGF system shall be designed and constructed to maximize the maintainability of the system. All components, sub-assemblies, or major assemblies shall be capable of being maintained or completely replaced within 3 hours or less during non-traffic hours. It shall include the time required to remove the components, sub-assemblies, or major assemblies from the MGF system for the purposes of replacement of worn components or the rectification of faults. All this work shall be done entirely at the platform.